Okay, in this video, what we'll do is we'll go through and show how to define a set of simulations in a CSV file. So that's sometimes convenient to do is to go through and create a CSV file that has every row is a separate simulation and every column are the characteristics that you're changing. So sometimes it's really easy and convenient to be able to load those files and in a lot of applications and go through and analyze the results that way or analyze what inputs, especially if you're doing a large number of simulations. It's convenient to be able to create a CSV file and define parameters in the CSV file and run a simulation that way. There are also tools such as the large scale workflow, which can be used to generate the CSV file. So that's another reason why it's sort of convenient to be able to define simulations using a CSV is because it's a common format that's used quite often in applications. So what we'll do is first define a quick CSV file in the format that Autonomy takes. So we'll create a new script. And in this case, what we'll do is the first column has to be the name of the vehicle. So it's called vehicles column. Then what it's looking for is after vehicles column, it's looking for either parameters on a system or it's looking for paths to files to change. So what we can do in this case is we'll use a path. So vehicle, VPA, engine, plant is the path to the engine system. And it will know based on the fact that it's a path that, oh, I must be changing something like an initialization file, a pre-processing file, a model, something of that type. And then what we do is we put in a parameter. So in this case, we're changing the engine power. And maybe we want to change the coefficient of rolling resistance as another parameter. Vehicle mass is also another parameter that we often change. So we'll define vehicle column, a system that we're changing the file for, one of the parameters, the engine power, to the wheel rolling resistance coefficient, and then the vehicle mass. And then at the very end, we'll append this cycles column. So I have some vehicles already defined, so let's just pass in. Let's see. We can use the vehicles that we used before. If I go to our previous example, let's take these vehicles. So what I'll do is I'll take these vehicles, I'll take the first vehicle, put comma, and then I'll just change the engine file for each of these vehicles, which is convenient. So I'll just change whatever the default engine file defined in this A vehicle file, we'll change it to this A init. Then we'll change the engine power. We'll change the rolling resistance coefficient, make it something very low. Make the vehicle mass something very low, just so that we could tell it's changing. And then here we could put a list of acycle files or process files. So I'll just show that you could put an entire list. And instead of defining it as separate simulation runs on separate rows, what we can do is just append another cycle and separate it by a semicolon. So this line defines one simulation run. So what I could do is I could just copy this line and we could increase the power and do 85 kilowatts. We could make this 0.06. We could add some mass, keep the cycles the same, or we could change the cycles. We could run it on a different set of cycles. We could run it on just a highway cycle. I'll copy these two lines and then just change the vehicle. So we'll do 4 simulation runs this way. So I'll just put in the crank starter, integrated starter generator, changing the engine file. It has the A init extension, so you want to make sure that the file extension's there. That's how it knows what it's changing on the system. So it knows that it's targeting this system, vehicle, VPA, engine, plant. Make sure that it has this final / on it. That's just kind of the expected formatting that the path has. That will make sure that it finds this system, and on that system, it will overwrite the existing A init file. So this is basically an overwriting operation. It will just overwrite what's there already with this file. Then it changes the engine power to 80 kilowatts. It's changing the rolling resistance coefficient. It's changing the vehicle mass, and then it's running it on these cycles. So we'll save this as a demo run 1.csv. So that's the CSV file that will run. I'll create another script here. And in this script, what we'll do is we'll put in the PXF run multiple vehicles in the settings to have it run. So again, we'll instantiate a PXF run multiple vehicles dot create using the defaults. Then what we want to do is this time we want to set the run table. So the run table is this table that we have defined here in the current directory. So that's called demo run1.csv. Then we want to set the number of rows. This is just to make sure that it knows the size of the table. When the table is very large, it's convenient to tell it the size, so it doesn't have to load a very large table into memory, taking time to figure out what the actual size of the table is. So what we have here then is 4 rows. So 4 simulation runs. We could run the number of parallel runs. We'll just make this 4. What we could do is we could also set up a log file so we could log the results. So to turn on the results logging, we set log results to true. And then we set the logging options. There is a log file creation location. And we'll just save it into the results folder that we created under development. And in this case, each worker, so this is sort of considering that you're going to be running thousands, tens of thousands of simulations, and each worker will be maintaining its own its own results file that you can merge later on. So let's just call this demo results. So what this is saying is each results file is going to have a prefix. So we're going to just prefix it with, I could put demo run 1, so we know it's for the demo run 1 results. So that'll prefix each log file. Then we want to make sure that we create a few extra fields on this structure. There's tracking properties, which you can set. But in this case, we haven't set any, so we'll just set that to an empty. Again, we want to do logging options, .log value. So we want to log individual values in the workspace. So we're logging the engine, plant, scale power max desired. And we want to log the unit. So there's a unit field. For now, I'll just set the unit to empty, but I'll just keep it as the default in watts. Let me move this out a little bit. That's the log properties. We're logging values. This values that it's logging, we're going to log a few values. So let's keep that. Now we want to put into our results table maybe other information. So maybe it's convenient to also see the rolling resistance coefficient that we set. So let's make that second parameter we're logging. And then the third parameter we're logging, the vehicle mass total. So that's the third parameter. So those are the input parameters. So we could align them with the inputs that we're running. Then let's also say we're logging the result. So it will look into the result workspace and it will access, in this case, engine.plant.results.fuel consumption.total. We could also log properties on the class that's running. So it would be convenient to have the log properties of what we're running, what cycle we're running. So these are properties on the PXF run cycle class. So that's what PXF run multiple vehicles is using internally to run a cycle file. So when we define an a cycle file, it's running those a cycle files. So this is a log property, and let's log the, I don't know, number. So this would be the first log property. This would be the second log property, right? The log values has a name and a unit. Log properties are just the properties on the class that's running, so that's cycle and number. Then we could also log path because we're changing the engine initialization file. What we'd also do is we want to log which engine initialization file we're running. What we could do is we could do log file paths to show the engine file. And it's on the vehicle, it's on the VPA, it's on the engine, and it's on the plant. And same thing here, logging options. Let me just copy and paste this. We'll put a forward slash there. And then we do logged type. So in this case, we want to say, okay, on this system in the vehicle, what type are we logging? Is it a pre-processing, initialization, scaling? In this case, it's initialization. Could be model too. And we also want to just make sure we set the logging functions we're not using in this case. But again, it's something that could run in the workspace. So these are functions that run in the workspace once the simulation finishes. So if there's some fuel economy calculation, energy calculation that you want to run on each simulation as it completes, you could do that here by specifying a list of logging functions that take the workspace in and then deliver a workspace result out. And then we just run the simulation. So run vehicle stop run. So that's our run file, or this is our CSV file that we're going to run. This is the example file. So let me save this as demo 7. From CSV. Okay, we'll save that. And we have the file prefix. We're not logging any properties. We'll run 4 number of parallel runs. We're not specifying distributed on, so won't be using the parallel computing toolbox. It'll just launch separate processes. So launch 4 separate MATLAB processes and give each one, in this case, just 1 simulation. So there won't be much in each logging file that's written out. It'll just be the one, be maybe 2 simulation runs, because we're actually running, well, in some cases, we're running 2 simulations, one for the UDDS, one for the US66. This simulation, though, is just a highway. And we'll save the engine power, the rolling resistance, the vehicle mass, and then the result, the fuel economy, and then some properties from the A cycle file that's being simulated. So the cycle and the number of simulation runs. And then we'll record the initialization file and then run it. So I'll just hit run. So that will run, and then we'll come back and look at the results and look at the logging files that it creates. We can see that it's setting everything up to run. Okay, one thing I noticed is that there was a little typo here. This second log property should have a name, not unit. So that's when I copied and pasted it. So now there's 2 log properties, cycle and number. So let's run this again, save it, let's run it again, and come back when the simulations have finished. Oh yes, and then also, so name was changed, but also path. This should have been a capital. So I had a lowercase, and this was unit, but it should be name. So there were just a couple of typos there. So I believe it should be okay. So let's now run it. Okay, now that the simulations are over, we could look to see the results. I type in result, and we could see that the past the result file are returned. So I can open one of these files. We could see that the information that we put in the log file was written out. So we get the vehicle information in the first column. That's a display name of the vehicle. We also get the cycle information that's written here. And then the cycle number. So we run the cycle once. So that information is written here. Then there's the engine power, the rolling resistance coefficient, the vehicle mass, and then the fuel consumption. And finally, a path written to the data.net file. So this is the location that the data.net file was saved. So that's one way that you can set up and run a simulation using a CSV file as the input, and then get the results also in a file, which is a pretty convenient way to run simulations, especially if you have a lot of simulations and you would like to load them in a table and kind of configure them through maybe a table and then run the simulations that way.